I think we can start now, more or less. And I mean, it's a BoF, so if you have some items to cover, parallel computing was a bit on the, not so much on our side there in the talk, but if you have something there, come interrupt. Offloading, OpenMP topics, there's some list of things to discuss. Additionally, we might continue with some items of which could be done, which Thomas didn't manage in his talk. So we have some C++ leftovers and a kernel language. The question is a bit, so someone has some preferences with what to start, but otherwise on the next slides, there's a bunch of topics to discuss. I don't know, any preference from someone in the room? Not.
If someone else wants to go first, we can go straight into the declare variant because it needs to be addressed. I think now is the time to do it. All right. Do you want to start? I can start. You start. Okay. There's still some disagreement on how declare variant lookup should work. And there's issues in the spec as well. I don't know how much we want to talk about the spec here today because it's not really an OpenMP meeting, but the examples that Jacob has given make sense to me, and the wording doesn't match up to them directly, unfortunately. Right now, where I'm at is I think that ADL should be disabled, probably, if we want to keep to the spirit of the spec. Otherwise, the spec needs to be altered to allow things afterwards as long as it's by ADL.
Well, I think if it's not a template, then
No, I agree. Yes.
Then the ADL should work only for what is before, and otherwise. So how do normal templates, where you, for instance, inside of the body call the function, from the base function call the variant function? I think it should behave the same.
Yeah, I agree, but the spec kind of is sketchy on that because it says nothing before, but with ADL it can find stuff after, but only by ADL. So that technically is a violation of the spec, but like it has to work that way kind of, but only with templates, yes, because if it's not templates.
Well, ideally, we should find out where exactly in the C++ standard is the normal behavior of templates defined in the name lookup, and just reference this place from the standard inside of an OpenMP. Okay. So as is in base language here and here. And that's it.
Yeah, so instead of saying name lookup in the spec, say overload resolution. I agree with that as well. Unless we choose to disable ADL, that's where the question is that, is ADL actually in the spirit of this? And I could see an argument either way. It seems weird to get rid of ADL there because then someone goes and does something and goes, I expect ADL to work, and then it doesn't. But if ADL is enabled, then yeah, we just quote the spec in the C++ spec in there, change it to overload resolution, not name lookup, and that fixes everything in theory because you did point out a passage that demonstrates that yes, the types, I mean, it's a little wishy-washy because they say compatible, and that doesn't mean anything, but we know what it means.
And it's also complicated by the fact that we have those append arguments and adjust args, and so it's not about, it doesn't have to be the same always, and for the SIMD related stuff, it will be even different always, at least on the architectures which do support it. But so we need some wording to specify in the standard, and until then, I think we should agree with the upstream language committee on the ideas which we want to do and implement that before the standard, because that will take 3 years or.
Okay, so would you like to go, Tobias? Okay. So when you say agree with upstream, what I'm not sure about is, do you mean like in the spirit of it?
Yeah.
Okay.
Well, basically, get probably Tom, and I don't know who. Tom and maybe Deepak, and get agree on that, and that's it.
If I got that right, the OpenMP committee now has a process to issue erratas to the document, so you don't actually have to wait 3 years, maybe, if that can be addressed individually. I have no...
We definitely should come up with a couple of test cases which include the ATL and so on, and show this is the way how it works in normal C++, if you call it in the parameter scope in late function type or something like that, and so we should do the same and have an OpenMP test case with the Clear variant where it makes a difference and say so basically start writing test cases for the behavior we want and submit them into the ticket, and if it's agreed on, then put it into our test suite.
Yeah, I think the three of us should try to come up with specification wording and create some test cases and give the argument and try to get that done kind of in time of the OpenMP face-to-face meeting, which is in a bit, it's in a week essentially it starts. So tomorrow in a week it starts. So I think it would be best. I'm planning to be there virtually, but I think in person, I think it's in Charlotte or so. I mean, that's East Coast US. Okay. But I think we should have an agreement among ourselves and a pull request and probably some arguments, because usually if you have pull requests and good arguments, then it can rather quickly get merged. This year's a technical report in November, and next year is the 6.1 release, and then I think it takes 3 years or so with nothing, and then comes the next release. So, and questions for you?
Yeah, and so the things we have to cover then are both overload resolution, and we just quote the standard there. I agree with you there. That's the best way to do it instead of trying to hack it the way that they've been doing. Then also, I think we need to clarify how deduction works. It should be as if it's called directly there, which makes sense because that's kind of what they want, because they said the types need to be the same. So it has to be forwarded, so to speak. Those things are important to me. And as you raised, the types don't have to be exactly the same. They're the same until append args and the SIMD transformations. So yeah, that will make sense.
SIMD is implementation defined because we can't guarantee the APIs.
All right. So I think that's good then for this.
Cool. Kind of
check.
So that takes.
Okay, so the question is whether we kind of start with some generic ones or whether you quickly want to cover some items, but I prefer to have it in a quick version maybe.
Yeah, sure.
Because we have a couple of questions, I think, to address additionally.
I don't have a preference, so if there are audience questions, that's always more important.
I think you can quickly go C++ extremely quickly, and the other one quick, but more.
Then, so earlier in the talk, I mentioned this Google Summer of Code project with the in-memory volatile file system. I said I would tell you why that's actually important, or important. It helps me as the maintainer of the NVPTX backend, because as part of that, I run the whole GCC test suite with C, C++, Fortran languages. And as it happens, Fortran has a rather powerful I/O system with formatting and all kinds of stuff, and they keep fixing bugs on that and add new test cases. And then when I run the test suite for NVPTX target, I always get fails because, as I mentioned earlier, normally NVPTX target does not implement file I/O. But what these test cases do are actually just write out some stuff into a file and read it back in and then verify that you got all the parsing right and the formatting and all that. And that's what we actually get with this virtual file system here. So that was actually my main motivation, just to make my life easier, because otherwise I always have to go into the log files and figure out, why does this new Fortran test now fail? Is that actually a problem? Oh no, it's trying to open a file. Yeah, not supported. Okay. That way I avoid that. I just wanted to mention that.
And there was something missing for C++ to be done. I think not to what's working. I think that we kind of covered.
Yeah,
but
so
what needs to be done.
To support C++ in offloading, quite a number of things had to be done. Preparational commits, generic infrastructure, libstandard C++ configuration, and then eventually enabled that. We built the hosted libstandard C++, not the freestanding one, for the reasons briefly mentioned before. The freestanding C++ does not allow for dynamic memory allocation. That may be changing, but that's what currently is implemented, and we actually can support that on a GPU and would like to support it because all the containers basically need that for reasonable use. So that's why we built the hosted, but then of course, again, we don't support all the fancy stuff in there, just what you can expect to work on a GPU.
Since in C++26, which obviously is not supported by OpenMP, they are making context for exceptions and context for concepts. Do we want to think about that? I vote no, but it's worth raising.
I'm not thinking about that right now.
I think if the user there are two cases. One is building with fno abstraction, and I think the agreement was that in that case you don't even have the context for exceptions because it's too hard otherwise. And if they are enabled, then the C++ frontend doesn't care about whether it's in target region or somewhere else. It will just evaluate it.
Mm-hmm. Yeah, whatever happens
so
in the front
it
end.
will work, and it's already
Right.
on the trunk, so you can play with it if you want.
But that's a remark here. So we built the GPU libstandard C++ libraries with -f no exceptions and -f no RTTY, because we don't support the underlying things or choose not to support them because it's difficult. Now, you remember the offloading compilation model that GCC has, where all the source code, including the offloaded regions, OpenMP target and so on, is parsed by the host compiler and then emitted into the offloading compilation. But I call this host flavored version of the code, because the driver, GCC, whatever, that you run on your host, of course, is configured to support exceptions, for example. So you end up with exception handling constructs in the intermediate code that goes to the offloading compilers here. And that happens, of course, very easily when you have some try-catch construct in some whatever standard library even. And it's not helpful if then the offload compilers just tell the user, oh, I can't compile it, because then you can't compile any C++ mostly. So what I did instead was add a new flag to GCN and NVPTX targets fake exceptions, and that is enabled by default if we are doing offloading compilation. And that means the compiler backend does not error out in those cases, but proceeds and does. There are several parts involved. Some just it doesn't emit any code, and that has the effect that eventually we run into. So we basically don't catch any exceptions, and eventually we run into the topmost handler. Like in C++, when you throw something and don't catch it anywhere, you get a fatal termination of your execution. And then we get that in the offloading code, which means if you have exception handling constructs in the code, that is fine. if you don't actually throw any exception, there will just be no ops basically. And if you throw an exception for whatever reason, that will cause termination of the process. And we agreed with the customer there that this is reasonable behavior in this offloading mode.
Well, that's actually what the OpenMP standard requires. I think it says that throwing an exception is pragma OMP error or whatever that. Yeah, I think it's fatal error or something. But I think I don't understand why do it on the compiler side. Why do just don't do it on the library side? So on the offload libstdc++ build just for underscore CXA throw just to the OMP error. Or?
I don't remember right now. There was some reason I did it that way.
Sure. Normally, yeah, we see the EH edges and so on. So you don't have to emit them in the offload code, but for the calls, you could just handle them.
I think I asked you the same question when I started at Bailey, and you had a reason. I can't remember exactly what it was, but for whatever reason, this was easier. Somehow, it seems like the other way would be easier, but this worked correctly, and it didn't the other way.
Yeah, that was actually easy to
Probably
implement.
the users shouldn't need to specify an option. It should just work by default.
MK offload, so the offloading compiler
Okay.
driver does that automatically. Okay. Unless you can override that if you want, but yeah. Okay, yeah, right, and then so that was one example, totally made up. We have for try catch. So we are in an offloaded region here, ACC serial, likewise OMP target. We have a vector in there, and then inside a try we push into the vector, and that of course has to dynamically allocate storage. Might throw, so without this fake exception thing we would get a compiler error here. But in this case we don't actually care because we just iterate over the vector and either there is something or not. So that compiles fine here, and we already covered that one in
maybe
in no detail.
after the OMP target lowering, we could throw away the EH edges and simplify the code that way.
Yeah, I had that implemented when I started this whole thing 2 years ago or so, but somehow it felt unnecessarily complex to have another pass to just remove that stuff.
Well, we already have the lowering pass for the offload code, so it would just
the other thing that
throw
really
away
was
the EH edges and clean up, and it's easy. Yeah.
the fake exception thing was 10 lines of code change or something. So
Maybe future work?
if anyone has any interest, of course.
I think that's on you then.
Right, yeah, and here was just some more complicated C++ code. Oh yeah, I want to show that quickly. We have the problem, as I mentioned, unless you are in a shared memory host device configuration, you have to transfer data between the host and the device to actually compute on anything. We currently cannot map C++ container objects, for example, because that requires more description of the data or how it is laid out in the compiler and all weird of stuff. But what you can easily do is take the raw data with the data member function and the size and then transfer that data, and in the offloaded region use a standard span to basically set up a view of the data in a C++ way, because then you can again use whatever C++ stuff that your lambda, begin, end, iterator, and whatever stuff that you would like to use there. Right, yeah, here, for example, for no particular reason, standard for each with a lambda, and offloaded C++, so all that magically then works.
Is this the time to talk about what needs to happen for mapping standard structures to actually happen, because there's a lot of specification work that needs to
Yeah, we
happen there.
don't need to resolve that here.
No? Okay, great. I don't want
Well, I mean, partially, maybe first of all, it was a bit seen as neat, but I think there's no concrete action. I mean, there was some discussion at ICHPC in Hamburg this spring, but in principle, if one has access to the class definition, I mean, the promise, the member is private. You can have a declare mapper, and there's actually an implementation issue. It's supposed to work if you put it into the class, the declare mapper, but neither the not complete much draft patch just for declare mapper is working, and the Clang doesn't implement it either. And putting it outside of the class doesn't work because it's private, but inside it should work. So in principle, there's something which can be done, but of course with the standard template library, you would put it there.
I guess also for templates, because for templates it's hard to define it outside, because you can have a template with just the OMP declare mapper inside of it. So.
We did talk about some syntax options. There is an issue open for that, but I think the only real way to do it is say, okay, whoever made the class has to do it because they know the internals. Trying to hack around it is just a waste of time. And there's another issue with something like a list. You actually can't map it right now because you have to be able to iterate over each node of the list, which you can't do in a mapper right now. So again, needs more specification, but we don't have to talk about that today unless someone has any big ideas.
Yeah, anyway, that was not a goal of this standard library enablement project. Of course, it needs to be resolved in some way, but yeah, not
to do it.
I'm not going to do that now. I mean, I may contribute if a
Or at least
customer
there's
happens
some
to ask.
workaround which kind of works, and
Yeah.
with, getting unified chat memory a bit more popular.
The uses that are relevant on a GPU. The uses that are relevant on a GPU work, in my opinion.
Yeah.
Okay, good.
All right. The other thing I had was this idea of a GPU kernel language, CUDA-like at the abstraction level. But I have some slides, but we can also talk about anything else that people want to talk about.
Maybe in kind of 3 words, what it is. I mean, the issue, as said before, is that the performance, I mean, there are several things. One is the performance is usually, if you do it the direct way, better, like Cocos does, and I'd also like to have Cocos using GCC, which won't work if they use essentially CUDA. There are ideas in the language specification part, and there are steps going into this direction to have something more direct in the OpenMP part. So having the direct, this is now a kernel part is missing, but a lot of steps where in terms of function calls or specifying things more and more enter in the OpenMP 6 and beyond standard. So that would be useful. And yeah, I mean, that's kind of having some generic infrastructure and saying kind of this block is more or less raw input to the GPU. And then, of course, one needs to have some call to actually launch the kernel. And
so should I go through this quickly, maybe?
And that's the rough idea. Maybe you have something like 2 slides or so.
Right. So we have determined, as you saw in the benchmark results that we had up earlier, that the OpenMP offloading performance is mostly worse than OpenACC, not in all cases, interestingly. That's because, and that's not a deep analysis, but what we have learned through the past decade, OpenACC has lighter abstractions, lighter device-side runtime library code, because none, and less runtime state compared to OpenMP, which has a lot more ICV, internal control variables, that may affect the execution, and so you have to deal with them at runtime. So there was this idea to map OpenMP to semantically matching OpenACC constructs that Chung Lin has been working on, and that indeed does improve performance of certain OpenMP offloading codes to the corresponding OpenACC ones. But that's not sufficient because the OpenACC offloading performance also is not ideal compared to other compilers. And that's because the OpenACC lowering in the compiler still goes through several stages and has to decompose this directive for loop things into a reasonable structure to map onto GPU facilities. So the idea here was to get rid of that and, as Tobias said, go to the bottom level of GPU programming, which is at the CUDA level, and I have an example, a very simple one. You write like serial device code, which the compiler then can rather easily translate into the PTX or GCN assembly thing, and everything else, like the parallel invocation, the configuration of how you schedule your code to the GPU, that is done manually. The memory transfers are done manually. And so that doing that would give a way to see where GCC is currently losing performance, if it's maybe in the device code generation. Currently we don't know, or if it's the other things, and then we can gradually try to address them. So here is a simple SEXP that's a float a times x plus y operation on a vector. In C, C++, very standard, you will understand. With OpenMP offloading, this example here does an OpenMP target map with all the relevant data, again, to transfer data between host and device, and then in there does, well, that's actually not correct, but anyway, that should be OMP target teams, I guess.
No, the target you have already there. It has to be closely nested, but
okay,
you have.
All right, so it is correct after all. That is directly this code, just plugging the OpenMP pragmas in front of the loop and the region here. Now with CUDA, you do this another way. This here basically corresponds to the region that we outline for target compilation, so that's actually a separate function in CUDA. And then in there you have scalar code, but you have block index and block dimension, which is one part of the GPU launch configuration, so the number of threads that you launch, and then you have thread. Inside each block you have threads, and they can be multidimensional, all that. But that's a very simple example. And then this thing here that is called SIMTs, single instruction, multiple threads, right? That gets launched for all relevant threads in parallel or in any kind of concurrent order, not necessarily all at the same time. And each individual thread computes the index that it's in, here multiplying block dimension with my block index and then adding the individual thread index. If I'm below the total number of threads, because you may not be actually using all the threads, then I do this computation on this one array element index, and then I'm done. So that's the actual offloading code, which CUDA marks up with this global attribute in a way. This down here is the code that executes on the host, so that's not directly like it's written. That's a separate function here, the main function in a way, or SEXP function here, which sets up the memory manually, CUDA memcopy or whatever else, to the device and back from the device. And this 3 angle bracket syntax is how you launch a CUDA kernel on the device. Here specifying the launch dimension, so the block dimension and the thread dimension, and pass the arguments. That's, I guess, also not correct, because that should be the device addresses, whatever. Yeah, anyway, that... Yeah, that as well, need to allocate that, but that's, yeah, I copied that from this scientific publication, so.
Yeah, one of the problems, of course, is that the pointers to the original code are not restricted, so you can't do that, what you do at on the CUDA side.
Yeah,
because you assume that these are independent vectors, but they aren't, because you don't say that on the other side.
But the OpenMP pragmas already says,
overrule that?
Yes, there are no forward dependencies.
Anyway, my idea. So I would like something like that in GCC, not necessarily the CUDA syntax, unless Nvidia wants to pay us to do that, but they don't. But something at a similar abstraction level. And as it happens, so Clang actually supports CUDA syntax, so we could also do that if we wanted to. And then what has happened, that's from 2 or 3 years ago, proposal of an OpenMP kernel language, adding that to OpenMP, basically OpenMP programming at the abstraction level of CUDA, or HIP, which is basically a clone of CUDA in that regard. And that is actually in process of being standardized, or parts of it have already, so that will be in an upcoming OpenMP revision. But that will take time to actually for everything to settle down. So I don't want to wait for that, because we want to use this for our performance analysis tasks.
But if it makes, for instance, a TR, you can start just implementing it.
That's true. Yeah, if that's sufficient for the things that we want to do. But I was thinking about.
Well, the main one of the reasons why normal OpenMP is slower is, for instance, the different levels of the variable sharing.
Yeah.
So that variables at the target level need to be shared by all the teams and so on. So that's why we had to invent the soft stack and stuff like that.
Yeah.
But I think in principle there's still some merit of getting the exact syntax working, because there's a lot of code out which uses that, and it's a bit clearer essentially what needs to be implemented in terms of function, because in the OpenMP there's still work on this one, but they have now to add, there are different things. You add things to specify essentially how the kernel should be launched. You specify things how you get these special named values, which you showed in the previous one, to get the block and so on indices and so on. So they add piece by piece, but it might be not trivial to stitch them together, and there's still parts missing.
Yeah. What I want to avoid is that we implement small part of CUDA here, and then people think, oh, GDB now supports CUDA, let's try. Oh, it doesn't work, shit. We had that before, like with OpenACC, in a way. So I would rather make this some other syntax for now. We can easily use Pragma, GCC, CUDA, whatever, and then have clauses there and do it that way. Right, and that way, what I said, we do the device code partitioning to the several layers of parallelism manually and the memory transfers. And then the only moving part is the actual PTX or GCN code that we generate. And then we can better get an idea where if we are losing performance at that level, and if not, then we can work backwards up the stack and reintroduce abstractions that GCC has by having, some weird form of half CUDA, half OpenMP syntax, and try, for example, also use this to come up with optimizations that the compiler can do to optimize actual OpenMP code. Yeah, right, that's basically what I said, then work backwards up the stack. Yeah, so, and given that this is coming into OpenMP anyway, why not start early with a GCC local implementation for our own use, and then once OpenMP has all the syntax and everything settled, then we can switch over to that with hopefully roughly matching semantics. OpenACC, by the way, also has a work in progress for doing that, but nobody worked on that recently, so I'm not sure if that's coming anytime. But so nobody is wildly objecting, I take from that. Okay. Good. What else?
More or less some list of items in the DIY topic I more or less randomly wrote down, but I think there are much more. I mean, one of the questions was after which point we want to bump the version number of OpenMP to start with one of the lower items. I mean, we currently claim that we have full support of 4.5, except of some bugs. And the question is whether one should now move to 5.0, 5.1. I mean, there's few things missing. Partially, they are still being merged. But
maybe just bump it to 5.2.
Well, or bump it to 5.2. I mean, there's essentially one part missing for...
Well, the major is OpenMP T and D, but that will take time.
Yeah.
If somebody starts on it, at least.
People have started on that, but you know.
So my question is actually at the very end of it. I'm technically working now on an accelerator, a different kind of accelerator. So my understanding is what kind of steps, if there's anywhere I can find tools or guides or documentation to understand what things I need to do to port OpenACC, for example, to this architecture, to this card. I already have the GCC backend for it, so I can compile code for the device. So this is my thing. I didn't want to ask this question, but since I see it actually in the last point, I wanted to.
Totally applicable here, yes.
So, right question, right, BoF.
What you need, so you have some backend for scalar code generation.
The backend to generate for the device.
Yeah.
So yeah, I definitely have a runtime to control the card and tell it to run things in which threads and blah, blah, blah. Right. I do have a backend that generates GCC code for the architecture. I have control of the firmware and everything. I just wanted to understand if this is something, I mean, it does make sense to me, given the hardware to support something like OpenACC. I just wanted to understand what kind of like effort it is. And
yeah. So we've done it twice, suffered through a lot of things. Yeah. So high level, what you need is in the back end or in the middle end in GCC or back end in combination in some way, you need a way to schedule OpenACC, OpenMP code to the workers, whatever that you have. And then you need a plugin in the libgomp runtime library, which uses your interface to the device. And you can start small to just get it running at all single-threaded and then add the other stuff. Of course, there is no documentation really how to do that because, yeah.
Okay, so it's just about reading code. Well, there are two plugins written in the hooks, so you can look. You have all the sources, so you can see what. And
yeah.
And then in the make files you need to add some things, so register it as a offload target, basically allow users to configure, for instance, x86-64 host with offloading support for this target. Then there's need to be a rule for the make offload command, which will do the shuffling what is needed, and implement a few target hooks, and that's it.
My baseline question is like, this whole support was extremely hard-coded to certain backends, or is not? And
no,
I mean, there's kind of, I mean, one part is, I mean, there are kind of the two parts. One is the code generation part, and one is the runtime part. For the runtime, the libgomp has a subdirectory where you have plugins. And in the main part, it checks, is this plugin available, is this plugin available, and that one provides says the device is there and some properties of the device, and then later loading the thing. So that's kind of one part, and the other one is in the compiler, making sure that everything is configured there, so that one writes out or that the LTO data is then read in by the LTO plugin for the offload part. We usually have this MK offload one, which is a host program for each device code, which on one hand runs then the device code LTO compiler plus sets up some things. And among those is also we have the list of functions in table on the host side. One needs to has that on the device side, and one needs to link them, and essentially one writes in the MK offload the code to add as kind of as a constructor to go into the runtime library, and there it sees the image, and then one loads the image or registers the image in order to match the things up, and that kind of has to happen. So you have the plugin which knows the device at runtime, and then you have kind of this MK offload which drives your LTO and does this constructor generation to make sure that you register.
So in general, like new architecture to offload are welcome in a way?
Yes,
Yeah.
sure. We like
It's
to
up
help,
to
of
the
course.
architecture, it's up to the state, but in general, like, yes,
Yeah, I think the first question is if it's a backend which is already upstreamed or will be upstreamed. That's the first step. Yeah. And also, what is really nice so that users actually can build it in open source environments is, for instance, with CUDA, it's a proprietary library, but we have a CUDA header so that you can actually, it is DL opening the library and it doesn't rely on it during the GCC build. So that's a nice thing to get working without support, and then plug it in if it's provided proprietely.
Yeah, and we are, of course, here to help. Even though knowing you will figure out all the hard details and tell us how to do it right.
Also, for declare variant and meta directives, the backend needs to say which ISAs it supports and what's the architecture name, so that the host can know these ISAs are possible, and so they are not thrown away immediately or optionally when you enable the backend.
I'm pretty sure you just answered my question, so I apologize, but is there actually any practical reason why we need to do all that in the middle end and the back end? Why can't it be in the front end that we do a lot of the declare variant resolution? Is that, what do you think?
Well, in the front end, we can decide something which, there is a difference between GCC and Clang. In Clang, you have multiple Clang invocations. One is for the host and one is for the target. And it does everything from the parsing. And we chose not to do it that way initially, because it's really dangerous, because if it allows you to use the different defines and stuff like that, that's in some ways nice to the users, but they can just have ABI incompatible structures and stuff like that. And so it's really easy to get stuff wrong. And so we did it with the LTO, so we parse once, and decisions which we can't make in the front end differ until the IPA.
Just to be clear, is there any? So it's practical rather than necessary that we make it in the middle end area, because we in development we do run into some problems where it feels like some of the things in the Gimplifier maybe belongs on the front end, but because as you said, we don't know until we get there. For certain things, we have to remember until the Gimplifier and then make those decisions at that point. But yeah, that's.
I mean, parts we do. I mean, we have this begin declarant, end declarant, and at this point, we already quite early doing parsing for certain things. The specification says one should. For others, actually, they say one shouldn't. In a way, for elite code, they say, and if we know that we don't support this architecture, or where they asked, is this compiler vendor, I don't know, Intel, then we just ignore it. And that part, I mean, the function there in the middle end a function, but you call it from, I think, OpenMP general, also generic, I forgot the name. They're generic. There you have to call, and there you already remove things, and that happens with the begin end declarant trend quite early. But I mean, that's a bit different to some of the decision whether you do some call side things. And for others, it has to be relatively late because you need to resolve a lot of things. Like I think some parts could be done earlier and towards the end of the front end, but definitely not direct parsing, and probably, yeah, I mean, some parts only after doing the split off, knowing whether it's not the offload compiler or not.
It was done in the Gimplifier as the main thing, and then later after API, because there were some discussions if some of the decisions couldn't be done only at the end of translation unit. And yeah, I think it's fuzzy in the standard then.
Yeah, I'm starting to see why it probably simplifies things a lot, not having to know the full OpenMP context when we're in the front end. So it does make sense. Now I guess the question is there a point in moving the things that we can into the front end, or should we maybe be moving more things into the Gimplifier? Or I mean, we do already have another stage as far as I remember. So.
Well, moving to the front end means you write it three times. So. Yes. I think it's possible to keep it in OMP generic and call it perhaps from the front ends once again, and I agree with that, yes. and with some flags that it's in from the front end, and so it tries to be even more secure and resolve only what is really impossible. So, for instance, if you declare variant or meta directive is for some ISA on AMD 64 or on ARM 64 and you are on Intel, then it will just never be enabled. So you can filter it out.
Okay. Yeah, that does answer quite a bit of that. But something that what I want to do, and I'm pretty sure people will be unhappy with it, at least upon first reading of it, is I want some generic OpenMP routines for parsing certain parts of all of it, and having a callback to parse expressions that are specific to each language. So like for C, you have the C callback for expressions when it hits an expression, and C++ does C++ stuff when it hits an expression. So now we have the logic in one place instead of 3 times. Would it still have to be?
Fortran is still separate, or? I mean, in your idea, you say common is common C and C++, or common...
I think it would be the same. It would be common across all 3, ideally, unless there's significant technical reasons why not.
Fortran has a different IL, so it's hard to... Unless it's a function which you call on something which is not a tree.
Yeah, that does cause problems.
Yeah.
So maybe not Fortran then, but yeah, that's what... Because to me, the code for parsing the actual grammar of OpenMP being repeated 3 times is really annoying. It's repetitive. It feels a lot of it's clearly copy pasted, and that's never good. It creates maintenance problems, and that's something in the future. And granted, I understand people don't like the callback hell and all of that. For good reason, like it can be very difficult to wrap your head around that sort of code. So I want to avoid that. I don't want to make people hate working on the code base even more, but I do think that we can maybe genericize some of this hopefully in a way that everyone's happy. I don't know. What do you think?
Well, but if you look at the code in detail, it's not the same, it's similar.
That's the problem.
And it's very different. When it's parsing, for instance, it's really it uses complete.
Oh yeah, I remember what the problem I ran into was.
You have this C++ parser structure and C. Those are completely different things, and you do different ways how to skip to the end of statement and whatever. So you can't really merge it easily. You can use helper functions when you create the trees. You can, and we already sometimes do. We have the C family OpenMP, COMP, which can. We could move more stuff in there, but sharing with the Fortran front end is really hard. And
The problem won't happen.
another thing where declare variant is unresolvable immediately is, for instance, if you are on x86-64 and you ask for some ISA, it's not enough to look at the current function, what ISA it has, because we have function multiversioning.
Yeah.
So if it's a multiversion function, then you could have it for a different ISA.
So there's so many reasons we have to admit it into the control. So that's definitely out the window. It has to happen in the middle end for sure.
Anything else, the audience? Otherwise, I was a bit wondering, I mean, well, that's the right audience, but one part which we really want to do soon is the, shall we, general or?
General is for C.
Then?
It's for no, not OpenMP. It's
Okay, but then, I mean,
front
discuss now or not, otherwise for the device side, and probably goes enabling some libraries as well. We want to have some inlining from libraries. So currently, I mean, all the output files in principle are collected. So there's one interprocedure optimization in the sense that all offloading code is handled by one LTO, but not the runtime libraries. So we want to have LTO also via, I don't know, fat libraries also, or something on the device side. That would be the next one to come. And for the AMD side, it's ELF format, so fat libraries in principle should work, but there we need to have the linker support, and I'm wondering what other issues we might run into, and probably we should also go through some of the issues where some libraries, I think lib standard C++ and lib Fortran currently have issues that, or PRs open that they might have issues or have issues or had issues about enabling fat libraries. So it would be kind of one of the next steps. I don't know whether.
We need to be careful about stuff like inlining malloc implementation into code, because that's kind of
make sure to place no IPA on the
yeah.
instructions.
Yeah.
So is it mostly a driver issue, right? So that the LTO currently, the offload LTO does not get any library IL is an issue, that there is no additional LTO wrapper driving thing running, right?
There are.
I think one important issue is that for the offloading, we run it as the offloading LTO.
Right.
But the host libraries for the offloading are as if it's a host. And the question is if we can compile this LTO together when it's a different kind of LTO.
Yeah, so we will figure out.
There will need to be some work on.
We will have to figure out.
And for PTX, we currently emit the libraries as text. So we would need to compile it twice. One is with thin LTO, so into ELF objects with just LTO and no PTX, and one with the
Thank you
text.
that you have exactly the same idea I had. To basically have a multi-lib that has the thin LTO code and the regular stuff that we already do, and the thin LTO code would go into some small ELF wrapper, basically. Isn't there even a simple ELF or whatever in GCC source code in the libLiberty or somewhere? And then we have to...
there was also the discussion of emitting, that was about the .o files, emitting them directly without invoking the assembler for LTO.
There's a sum of code,
Yes, yes.
Unfinished sum of code project. That's
Yeah,
basically
that could be useful here indeed.
that's mainly for the output of the LTrans objects, and also from the VPA phase. I'm not sure about the compile phase. At least when you have the fat object, you still need both. But for the syn object, it might also work.
Another problem is that for PTX, we don't really have an assembler, so we would need to compile it as some other, choose randomly one of the host targets and emit ALF code for that, or because we shouldn't invent PTX ALF or.
Well, there is NVIDIA has ELF, CUDA, whatever their tool is embedding PTX, but I'm sure that isn't documented properly. At least I wouldn't do that because why would they? We don't want to interoperate with them, so it would be.
Do we use relocations? Oh, do we use relocations inside of the LTO sections, or? If without relocations, then it will be definitely
it's just
easier.
a stream of binary data.
For debugging, for sure, but for PTX, we probably don't care about debugging.
You might care, but we have to start somewhere. And then we have to figure out so currently we are using the LTO front end for offloading compilations, and then we also need to use it for proper LTO or mix it all into the same thing, so we will have to figure out some code paths there, but that's,
It should work in the same context.
In some files there is if def offload compiler, and then do that or do another thing, so, but that's stuff, we can resolve that.
And on the AMD side, we have to see how to handle it with the linker plugin, which would be, the three options, trying to get linker plugin working with LLD, or implementing it in Mold, or implementing in the BFD linker.
I think we do want BFD target for GCN because implementing the BFD shouldn't be difficult. Implementing an assembler is kind of it's not impossible, but nobody's going to do that. But implementing the BFD support for GCN is probably a few weeks worth of. So it could be a sum of code. No, I don't suggest that.
Maybe you just need to implement the relocation. And because it's not dynamically linked, you can skip all the PLT stuff and TLS transitions. Then those really take time, yes, but basic. And you want, for instance, object dump and stuff like that to work on it. So
I think object dump works currently or not. I'm not sure.
No. Well, but object dump will want to disassemble it and then yeah. Okay, you can skip it.
Yeah. Probably want to have something to procedure optimization, but similarly something important now comes, and with Joseph patch, and at some point we also need to tune the profile guided optimization cost model to maybe on the device side. Interesting, LLVM, once they did something in this direction, they got worse code because the cost model was completely wrong. On the device side, which, before PGO did not really matter, but afterwards they had issues, so that might be one of the tasks one might want to do. And Then probably the general issue what we keep running into is having the host data available and then running a device. I mean, like Andrew now enabled some masking support on the device side because the host side doesn't have it, and overriding the vectorizer settings. So that's the, I don't know how to handle those things best.
That's maybe a more general problem to mention actually. So currently we use when you compile GCC-02, we pass on the O2 to the offloading compilation. We do not, of course, pass on any -m something because that's only for the host backend, but we do pass on all the params as well, and they are partly also specific to the backend, like the vectorizer has a number of params to affect vectorization, obviously, and they may be very different from host and device, so it's not the right thing to just blindly pass them all onto the offloading compilers. So we will have to figure out two sets, basically, which are applicable, which are not.
Well, I think like for the vectorizer ones, or maybe also others, when we run into them, there's a possibility to make them not params, at least not params that have different defaults in different backends, but turn them into target hooks for the defaults. Well, because
we also have the global options set. So we should only pass the parameters which were explicitly set by the user and not implied by the backend.
Yeah, so Andrew,
I think that the issue is we save those in the optimization struct, which is a binary blob, right? We attached to the functions, and I'm not sure how we.
Even this, and in that case, the offloading compiler can throw away.
Sure. It can override, like for this for the epilogue setting or for the masking setting. There's no good reason that this is a param, the default handling for the target. It's a historical accident basically.
Okay.
So we can also just fix that.
So Andrew has recently added a no offload flag to the options, and then we can at least mark up the ones that we definitely currently don't want. Still awaiting a proper solution whenever that comes.
I mean, officially we're in break since 6 minutes, and that's the half an hour coffee break before these, I think, general discussions starts about, I forgot the topic. No, steering tomorrow, but it's a bit more like about the
processes
and barriers, it's called.
Okay, thank you.